All right, so my name is Heather. Most people call me Weasel. I'm going to talk about JSON web tokens for fun and profit. Who here has had to implement logins and auth? And who here has used some form of OAuth to do that? Good. So some of you know what we're going to talk about, because we're not going to talk about SAML 2. So OAuth is a framework to enable us to get access as a third party to some type of service, either on behalf of the resource owner or behalf of the user. We get a limited access credential that expires. We start off by exchanging a client ID and a secret, and we end up with a token that is good for a limited period of time. Big difference between OAuth 1 and OAuth 2 is that OAuth 1 didn't require that tokens expire. That's a big deal because you're very vulnerable to replay attacks in that situation. Don't use OAuth 1. There are two main flows that we use when we're implementing OAuth. There's an application flow where we've granted permission in advance, and we are proceeding programmatically to obtain the token without intervention. The second one is where a user is directed to a login portal to enter their credentials, and then gets redirected back. And like if you've ever done login with Google, that's this flow. But the big key is that we never see the user's credentials. We have our own credentials that identify our application, and that is the only thing we handle. So there's two steps to OAuth. The first one being authentication, or auth-n if you've seen that. This is where we verify a user's identity. Typically we specify grants as far as what type of access we want to get. And if there's an error, we get a 403. So 403 forbidden is, I don't know who you are. The next step is authorization. Oh, yeah, I get to start over? Okay. I'm not doing that. All right, so authorization is the second step, and this is where we verify that a user has privileges to do the thing that they're trying to do. You received an access token in the first step for authentication. And in this step, we exchange it for a bearer token, and if we implemented them, refresher ID tokens, which we then use as our credential when we identify ourselves with a service. If you fail in this stage, you're going to get a 401. Usually this is accompanied by some very unhelpful message saying something like invalid grant. But that's because this is an auth API and we don't want to leak implementation details. So we're going to assume that that worked. I have a bearer token. Well, what do I do with it? So there are different ways to implement tokens. We're going to talk about JSON web tokens specifically. So these things are base64 URL encoded strings. A token is comprised of 3 segments that are headers, claims, and signature. The header is called a Jose header, which includes the type of token, the signing algorithm, and optionally, depending on the implementation, which we'll cover later, the ID of the public key that was used to sign it. Type can be a few things. Most of them in practice are just JWT. Very few of them are ever encrypted. Most of them are signed. In fact, I don't think I've ever seen a token that was not signed. The claims are usually details that need to be verified, such as who issued the token, when does it expire, OIDC or OpenID Connect contains user data. You can have information about the scopes it was issued for. You can have a lot of information appended to a token. It all depends on who issued it and what they're doing with it. So information exchange is one key part of this spec. The signature is a cryptographic signature of the payload and headers. We'll cover that more later. So why would we want to use these? The biggest thing is they're easy to use. They're easily discoverable. And the format is well known. The claims and headers are tamper evident. So if you go and change the expiration value in the claims to be like December 31st, 2999, the signature is not going to be verified. It will not verify. And it's evident that someone modified it. That said, the claims aren't secure. So any information you put in the claims could potentially be read by anyone. You could encrypt them, but that has its own implementation problems. So usually you could assume that anything that's getting transferred around a token is going to be base64 encoded plain text. So I have two examples. The first one, let's take a look at the Google Auth API. So this is accounts.google.com.wellknown, and this is the OpenID configurations. This is a user.
Can you zoom in a little?
Maybe? Where is my menu? Oh, there we go. All right. So this is a API that provides data about user accounts. So they're using OpenID Connect. The first thing is the issuer. And when you get your token, you're going to have that ISS value in your claims. You want to check when you verify that it matches this value. If you use any libraries to do that and these values don't match, it'll fail verification. The next, all of these are URLs that we would call when we're using their API. So for the step one, for authentication, this is a token endpoint that we call to get our access token. And then step two, this is authorization endpoint that we call to get our bearer token. We have this OpenID Connect user info URL, which we'd call to get an ID token containing user data. And this is the revocation endpoint that we call if we want to log out and revoke our token. So we have response codes. We have the subject. There's only one type. It's public. We can see that the tokens are signed using RSA 256. There are three scopes. We have OpenID, email, and profile. So if you specify these when you request your login, you're going to get back these details in your token claims, potentially. These are the various claims that a token can contain. So we have ISS, the issuer. We have IAT, which is issued at. We have name, username. Sub is the subject. Picture. I would assume this is something we'd get back if we specify the profile scope. Same with email, verified family name, given name. Email, obviously if we say email, we get the user's email address. And EXP is expiration. AUD is audience, and we'd want that to match our application saying that we requested this token. And of course, we have grant types, so authorization code. If we're doing the redirect flow where we send the user to the portal and get them back, we might implement, or authorization code might be a step that's implemented. refresh token is something we can request if we expect our session will last longer than the time that the token is valid for. We can request a refresh token to extend the session. Then we have JWT bearer. This is, well, we want to get a bearer token. I don't think I can. I guess I'm cut off. Huh. Well, believe me, there's 2 other grants on there. So, well, the final thing I wanted to look at with this is this JWKS URI, which, I mean, this to me is one of the coolest things about the JWT spec, is that this is how we distribute our public keys that we use to sign. So we have this endpoint, OAuth 2 v3 certs, and it's got 1 value in the payload, keys. And we have a list of keys. These are the current keys that Google is using to, these keys can be used to validate all of the tokens that Google's account API is currently issuing. So we've got here, the algorithm is RSA-256, the exponent is AQAB, and the modulus is, well, this. And use, we see it's used for signing. I don't know about you, but I really hate rotating keys and passwords. And if you use this type of implementation, you can do it automatically. So if your token is good for an hour, you stop signing keys with that token an hour before it falls out of rotation. Swap it with a new key. And problem solved. So that's the well-known configuration. Most of the big providers like Google, GitHub have this type of details posted. I'm also going to walk through how to issue these. So I have 2 examples that we're going to look at. The first one is using cryptography hazmat and all the encodings to manually generate a token. And then I'm going to walk through using probably the most popular JSON Web Token library right now, which is PyJWT. So let's get started. Do we need to? No. So, all right, is this readable to everyone? It should be. Okay. I'll just leave it full screen. Oh, and now we've oh. I think it needs to go the other way. This way. Go that way.
There it is.
Ah. Yay. Okay. So I guess I didn't do it right.
Oh, clip.
Oh,
One second, I might-
yeah, well, all right. Token. So first we need to load a key pair. Here I'm using the low-level serialization library to extract both keys from the PEM file. Now I need to assemble my headers, which there's no key ID because I'm just building a token here. I don't have any means to distribute keys. I'm going to have to contact my users in advance and give them the public key that they can use to verify the signature. Here's my claims. This token isn't valid an hour ago, expires in 1 hour. I'm going to use RSA 256 to sign it. It's issued by me. It's valid for me and you. So the first step, I need to serialize and encode the claims into bytes. Then I need to take the byte string, base64 URL safe, encode it, decode it to a UTF-8 string, and then I'm going to do the same thing for, well, I'm doing this for the headers, I'm doing it for the payload, and I'm going to join them with a period. Now I need to cryptographically sign that string. So this is another method out of the cryptography library to sign using my private key. I got to specify my padding, the hash to use for it, and a salt length, and so now I have a signature. So now I need to take that token string, append a period, and base64 URL safe encode the signature, then decode it to a string and strip the padding characters. So to retrieve the contents later on, I split on periods. I base64 URL safe decode the bytes for the header and claims and print them. I'm not going to go through verifying the token signature. That is tedious work. I think I've made my point for the terms of this example. We noticed that the token is signed, but the information in it is still readable even without the key. So let's go ahead and run this. So here we have my generated token. We have the header section here. This section here is my claims. And then everything beyond that is my signature. And I've got a syntax error in my code when I tried to verify it.
Better at coding issue.
Yeah.
Can you use column coding and code on it? Yeah, come in UTF-8 and call the bytes.
Yeah. Oh, so see, we now have bytes, decoded headers, whatever. And then the claims. So these are readable. We didn't even do anything with the signature or the public key, or private, yeah, the public key. So the next example, we're going to use the PyJWT library to do the same thing. I forgot how many lines are in the other file, but this is a much shorter example. So for this, well, it doesn't really matter how you load your keys. I'm just opening them as a file and then feeding the byte string into this algorithm or this method. And then I'm constructing 3 payloads. For example, I have the good payload. I have a payload that's going to fail validation because the token is expired. It's past the, it will be past the issue date by the time it runs. And for this example, the audience doesn't align. So now I have my process token function that encodes these values as a JWT using the RSA 256 algorithm and my private key. And then I'm going to, well, we're going to go through all these examples. So oh.
Yeah, what you're typing is invisible. Control L. Maybe. There you go.
Who cares about namespaces? All right.
Don't lie, Darren. What could go wrong?
So now signature has expired. Audience doesn't match. We didn't even get to this step of verifying the claims in the previous example because that was very involved. My point with this is one of the most popular libraries for doing this for a reason. It's easy to use, it's straightforward. You plug in a key, you give it claims, and you say, do the thing, and it will explain to you what was wrong very clearly. So if you want to implement JSON Web Tokens, I would recommend using a library such as this. Yeah, whatever, I'll just close it. Okay. So now that we've looked at what implementing a JSON Web Token looks like, are there any other details that we should think about before we say, oh yeah, let's implement these? Yeah. We talked briefly about the ID tokens earlier, the OpenID Connect tokens that contain user data. Your token expires and your signature won't verify after a certain point, but anything you put into that token cannot be revoked. It doesn't go away. You've already given that information out. So be mindful. Like, I have seen implementations of this that contain things like a user's birth date in order to verify is the person a minor or not. Like, well, because you have content rules for children. Don't do that. Use a Boolean. And so this is basically these, the claims aren't secure. This is basically a signature verification scheme. So it's really important to select an appropriate algorithm when you're doing that. So there are 3 algorithms you can use for this. We have RSA-256, we have HS-256, and we have ECDSA. All of these use at least SHA-256 for hashing. That's great. But 2 of those are asymmetric, 1 of those is symmetric, and those things have different uses. If you use a symmetric key to sign your tokens, everyone who can verify your signature can also sign tokens as you. Don't do that. And finally, we mentioned briefly, you can encrypt these tokens to make the claims secure, except all of that we went over with the well-known config goes out the window with that, because you basically, for this to be secure, you need a key pair per consumer, because otherwise everyone can read everyone else's claims. You can't publish them to a JWKS endpoint, and you have to rotate them manually. And for me, that kind of really that's really disingenuous for why I'd want to implement this in the first place. So that's a thing to keep in mind. And with that, I have some further reading here. I'll put these slides up on GitHub, but we have first the specification for JWTs. This user-friendly debugging tool from Okta and OAuth, or Okta and Auth 0, that can actually let you paste in a token and inspect it, which is kind of cool. Here we have the well-known config for the Google Accounts API and also for GitHub, specifically for GitHub Actions. And then, wait, go back. Then the OWASP guidelines for testing JWT implementations, which will cover a lot of things I just went over about using an appropriate algorithm, being careful with user details, et cetera. With that, do you have questions? Yes?
Why does cryptography hazmat sort of even exist? It's so hard to use. Is it because it's called like there's a lot of algorithms that make it like a reference implementation or something?
It's the core implementation of Python cryptography.
Oh, never mind.
So like everything that implements cryptography in Python depends on Python cryptography. And that module is called hazmat because even the docs will say, you need to know what you're doing to use this. There is actually a library called Fernet, or a implementation called Fernet, that they will direct end users towards for implementing this type of encryption. Actually, we can. This is symmetric encryption, like we would use to sign the claims, but it's very straightforward. It's easy to use. Same as JWT, the JWT library, the PyJWT, except this is for symmetrically signing something. So.
Why did JWT tokens allow you to do symmetric signing? What we would use this for other than getting it.
I mean, you could have some implementation where it's like you and one other person using these, potentially. I don't have a good answer for that. I mean, it honestly, if you need to encrypt something, you do that, like a one-way hash, and then that was why you would use that. You don't, yeah.
For microservices, need to have both have the secret key together that would never leave that service.
Yeah, so like one consumer, it would make sense, yeah. I mean, I would guess they just didn't want to limit people. It'll be interesting to see if, what that stays at going forward. But
Hypothetically, you could distribute like an X or like use a number station as a known random and use that. That's sort of like in practice.
Any other questions?
What were you saying about the birthday? Don't put birthdays
So for claims, let's go back to the Google example. So we look at the possible claims here. I have seen APIs that would include, as far as claims, if you requested user profile or what have you, one of the things they would include is your birthday. And the reason for this was because there was certain content that could have been, that could be age restricted. And so if you're going to authenticate with this API and use this platform, you had to check the age of users to make sure that your content was allowed for the user's age. I mean, yes, if you sat there and called this API every day and recorded the data, which is kind of a violation of terms of use anyway, you could figure out the user's birthday. But it's a lot harder to do if you just return a Boolean.